Hi everyone, Megan Zimba here for Wireless Design and Development, and we're at IMS 2014 here in Tampa Bay, Florida. I'm speaking with Guillaume Di Giovanni, President of Noise XT. Guillaume, why don't you tell us what you're demonstrating this year at this year's event?
Okay, well this year we have a new product that is a clock synthesizer that is actually a 2 megahertz to 7 gigahertz clock synthesizer, and we have a single and dual configuration. So this is very useful to drive A to D converters or D2As or DDS testing. So this is very low jitter. Compared to traditional crystal oscillators, you have about the same performance in terms of noise floor, so you don't generate so much jitter. So when you test a converter, you get a lot of effective bits. And this is important. And to demonstrate on the booth, we have connected the output of our synthesizer on the input of our phase noise analyzer, just to show the performance. And this synthesizer is also, I would say, quite affordable because we wanted to make it small, so it's about the size of a Pixie card inside, and because it's a single board, we can sell it for a very good price, under 4,000 euros for a single configuration. And you can drive this synthesizer with different inputs and outputs, so you can use either Ethernet, USB, SPI. You can also synchronize it to atomic clocks if you want, if you need the time accuracy. And the nice thing about this box is not only you can have a time accuracy, but you can also have what we call the short-term stability, very, very efficient, the low phase noise. And you can have it on both outputs.
So what was the main problem that you're solving for your consumers with this type of product?
Well, the main problem is very often when you want to test a digital chip, like a data converter, you have mostly on the market signal generators. They're usually very efficient, very good, but at low frequencies, in the 100 megahertz or tens of megahertz region, they lose a lot of performance in terms of jitter and phase noise. So we decided to make a synthesizer that would output at those low frequencies a very low noise floor. And so you can use them to drive A to D converters and obtain the best you could get, instead of those signal generators, which are more general purpose, while the clock synthesizer is really geared towards data conversion and also digital direct synthesis for oscillators.
So during the design process for this particular product, what was your biggest challenge that you had to overcome?
Well, the biggest challenge was to obtain on a single board a low-cost synthesizer that would be high performance. So the challenge is at two locations. In the location that we call the plateau of a synthesizer, this is to obtain a low phase noise, still using DDS technology because we want the accuracy, we want also the flexibility of a DDS. So we had to use a hybrid multi-DDS approach with a phase lock loop to lock the VCO. So this is quite unique, I think, on the market, and this is one of the technology that is inside our synthesizer.
Can you tell me what sets Noise XT apart from your competitors in the same market?
Well, we've been focusing over, today is our birthday, I would say, 22 years of operation. We've always been in the very low phase noise measurements, and in order to make very low phase noise measurement, we needed to have very low phase noise sources. So I think the main driver for Noise XT is really the low noise. We've always been involved in very low noise measurements or devices.
Great, well thank you Guillaume for inviting us to your booth. We appreciate the time.
You're welcome, Megan.
I'm Megan Zimba for Wireless Design and Development. This has been an IMS special. Thanks for joining us. See you next time.